Here is pre-calc day 2 homework of 3.4. The first 9 questions are asking you just to identify the parent function. So you don't have to graph these, you just want to strip the equation of the vertical stretches, compressions, the horizontal shifts left and right. And you should be able to write the parent function. Number 1, you should have x cubed. That's the cubic function. Number 2 is the absolute value function. G of x is actually equal to absolute value of x. Number 3 is the constant function, f of x, it's a horizontal line, equals 1. Number 4, h of x is equal to the square root function. Number 5 is the reciprocal function, g of x is equal to 1 over x. Number 6 is the linear function, f of x is equal to x. Number 7 is the greatest integer function, h of x equals the greatest integer x. Number 8 is the cube root function, g of x equals the cube root of x. And number 9 is the quadratic function, h of x equals x squared. The next set of problems are asking you to graph the original, the parent function, and then graph this one. So you should, all of these are involving one transformation. So the reciprocal function has asymptotes, and we did this in Algebra 2 last year. It looks like 2 arcs in quadrant 1 and in quadrant 3, and there's 2 asymptotes along the x and y axis. What a negative is going to be, this negative can be actually attached to the numerator to make this equation look like this, negative 1 over x. That would be a reflection over the, you could actually put this in the denominator as well. So you could look at this one as a reflection over the x or the y axis. So if you were to reflect this over the x axis, it would look like this. And this one would look like that. The next one is the absolute value function, and the parent function looks like this. And this negative inside would be our a value. That would be a reflection over the y-axis. So if you were to change, reflect this over the y-axis, it actually looks the same thing. Number 13, that's the cube root function. This is the one that looks like a snake. If you were to take the cube root of your numbers like 0, negative 1, the next one you take the cube root of is negative 8, or 1, 8, so 1, 1, and then we have 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. The cube root of 8 is 2, and then it looks like this, and then we have negative 1, and then negative 8, and then negative 2. So this is the parent function. And how I got that is I would take numbers that I can take the cube root of, like negative 8, negative 1, 0, 1, and 8. Those are the numbers I can take the cube root of. The cube root of negative 8 is negative 2, negative 1, 0, 1, and 2. That's the parent function. Now what this negative means, inside, you would multiply all the x values by negative 1. So you're going to graph 8 comma negative 2. Where's 8 negative 2? And I'm going to use a different color pen. So 8 negative, this is the new function, 8 negative 2. Then I would graph 1, negative 1, and 0, 0, and negative 1, 1, and negative 8, 2. So here is the new function graphed. So the negative underneath the radical here, that is an a value, and you multiply that, the x value, by negative 1. The greatest integer, we did these in class. If you were to graph this, it looks like these, a closed circle and then an open circle. A closed circle here and then an open circle here. A closed circle here and an open circle here. So now, if you were to shift this 1 unit up, it would be like multiplying all the y values by 1. So if you shifted, let's just look at this one right here, if you shifted this up 1, you'd have this would go to this piece right here. So all of these, if I put them all on one graph, it's gonna look like a big mess, but just so you know, that goes to that, just shifting it up 1. The next one is the square root function. The square root function, the numbers that you can take the square root of are 0, 0, and then if you put a 1 in, the square root of 1 is 1, and the next one that's easy is 4, 2, 2, 3, 4, 1, 2, and then we have 9, 3. So here is the square root function, that's the parent function, and this plus 4 means you're going to subtract 4, that would be a b value. You would take all your x values and move them over 4 units. So if you move this over 4, 1, 2, 3, 4, you get that point. If you move this over 4, you get this point. You move this over 4, you get this point, and so forth. So that would be the graph of that one. And the last one is the absolute value function, which is this one. And that minus 2 means you're going to shift your graph 2 units right. So all of these points are shifted 2 units right. So you would now have this graph here and here. Next page. (22, 23, 25, and 27 are asking you to write a rule for the transformation. So if you have the quadratic function x squared and you want to shift this graph 3 units to the left, 3 units to the left would mean to put that underneath it. So it'd be x, instead of minus 3, it's going to be plus 3, 3 units to the left. Okay, so that's what you would have for 3 units to the left. Then you want to reflect it over the y-axis. So that would mean you'd have a negative 1 in front, and you'd have x plus 3, like that. That's a reflection over the y-axis. And then you want to stretch it vertically by a factor of 1.5. So the 1.5 would go in front. And that would be your equation, just like that. Now if you wanted to distribute the negative, you would end up with negative x minus 3. Number 23, you're taking the parent function, the square root of x, and what you're doing is reflecting it across the x-axis, and you're going to shift it up 3. So this one would be, we're going to call this g of x. If you reflect it over the x-axis, that means you have a negative in front, and then you want to shift it up 3. That would be a 3 units up. 25, you want to take the absolute value function, and you want to shift it 3 units to the left. So you'd have x minus 3, that's 3 units to the left. And you want to reflect it across the x-axis, that would be your negative. And you want to shrink it vertically by a factor of a half. So the half would go in front, so it'd be negative 1/2, and then x minus 3. So that would be your equation. In 27, you want to go 5 units to the left. So it would be x plus 5, and this would be cubed, and you want to go up 4, so plus 4, and that's all you do for that one. For 28, they're asking you, 28, 29, 30, and 32, they're asking you to describe the transformations. Given this is the parent function, how do you go from here to here? And you want to do them in order. So for this one, you're going to want to pull out the negative 1/2. So you have a negative in front, negative 1/2, and then it'd be x minus 6. Because negative 1/2 times negative 6 is positive 3. So you would start right here. This is a reflection over the y-axis. That's your a value. You flip this, it's a 2. It's a horizontal stretch by a factor of 2. And then you move out here. That one's a reflection over the x-axis. I'm sorry. Backtrack, my bad. This is last, you're going to do this next. This is 6 units to the right. And then that's your C value, reflection over the x-axis. So let me repeat that. This is your A value, reflection over the y-axis. Flip that. You will horizontally stretch that by a factor of 2, then go here, that's B. B is 6 units to the right, and then reflect it over the x-axis. 29. Okay, we don't have to pull an A value out. This is B. B is, you're going to shift 4 units right. Then you move out here. This is C. There's 2 C things you can do. You can reflect it over the x-axis, and you are also going to vertically stretch it by a factor of 3. And then D is this right here. This is D. You're going to go 1 unit up. Number 30 is the greatest integer function. You don't really have to pull that A value out because there's no B value. So you start here, that's A. You flip that, it's a 3. It's a horizontal stretch by a factor of 3. There's no B value, but there's a C value. That's a vertical stretch by a factor of 2, and D is 5 units up. And number 32, you've got the reciprocal function. Now this one, what you'd want to do is rewrite this as negative 2x plus 4, and then pull out the negative 2 and you have x minus 2. This is your A value right here. That's A. And A is a reflection over the y-axis, and you flip it and it's a horizontal compression by a half. Then this is your B value. B value is going to tell you to go 2 units right. And this is your C value. C value tells you it's a vertical stretch by a factor of 3. The next ones, I did not give you a T-chart, but what you would want to do is graph each function and its parent function. The parent function for this one is the quadratic function, and that's 0, 0, 1, 1, and then 2, 1, 2, 3, 4. That should be enough for the parent function. And I'm just going to tell you, if you made a T-chart for this one, and your T-chart obviously would include the points that I just talked about, which are 0, 0, negative 1, 1, negative 2, 4, 1, 1, and 2, 4. That's the parent function for the quadratic. What these transformations are telling you to do, this one says to subtract 1 from your x values. So you're going to subtract 1. If you were to subtract 1 here, you get negative 3, negative 2, negative 1, 0, and 1. This number tells you to multiply the y values by negative 2. Multiply these by negative 2, you get negative 8, negative 2, 0, negative 2, and negative 8. And then this last number, the D value tells you to add 3. So if you added 3 here, you get negative 5. Add 3 to this, and you get 2. Add 3, add 3, add 3. Sorry. So your new graph should be negative 1, 3. Negative 1, 1, 2, 3 should be that point. And then it should be negative 2, 2. Negative 3, negative 5. Negative 5, and it should be negative 2, 1. I made a mistake. We are to add subtract 1, and then multiply by -2, and then add 3. Add 3. This should be a 1, my mistake. These should be 1s. These two should be 1s. Made a math error. So it should be this graph right here. Very easy to make a math error, be careful. And that's your graph. So this is the parent function and this is the transformation. Let's review. We took our parent function, we subtracted 1 from the x values, we multiplied the y by -2, and then we added 3. This one is easy. It's a linear function. Your easiest thing to do on this is just rewrite it in slope-intercept form. The parent function is this right here. And if you were to distribute 3x minus 3 plus 5, you get 3x plus 2. So that's 2 units up, and it's the same slope. 1, 2, 3, 1. 1, 2, 3, 1. 3, 1. And so forth. So this is shifted 1 unit right, vertical stretch by 3, and 5 units up. The next one is the absolute value function, which this looks like this one right here. Now what you're going to want to do, because this is your A value, you'd want to pull out a -1, and it's shifted 5 units right. So what you could do, you're going to flip this over the y-axis, and then you're going to shift it 5 units right and down 3. So if you do that, this is what your graph should look like. If you flip it over, here's your parent function. If you flip this over the y-axis, you get the same graph. Then you want to shift it 5 units right and 3 down, and this is what your graph should look like. And number 40, what you'd want to do is pull out a -2, and you get -2 times x minus 1/2. Now, what would you do to graph the parent function is this in black. And how do you mathematically do this? You're going to take your table of values, you're going to multiply the x values by -1/2. You flip that number, then you're going to add a 1/2 to that. And then you're going to add -3 to your y values, and that's what you should have. This is your new table, your new graph. Next, numbers 42 through 45, or you might have 28. You might have it written as 28, not sure what worksheet you were given. But this should be your next problem right here. It says f of x minus 1. Now, if you recall, you have f of x equals, it goes c, then a, x minus b, and then plus d. So, what this minus 1 is the d value. So all you would have to do, what you could do is make a table of values of these 4 ordered pairs. So if you looked at the 4 ordered pairs, this point is -4, 0. This point is -3, -1. This is 0, 2. And this is 3, 2 right here. So if you wanted to just do the table like this, what this is telling you to do, the -1 is saying to subtract, it's a d value, you're going to take these and subtract 1. So you're going to graph -4, -1, -3, subtract 1, you get -2. And subtract 1, 0, 1. And subtract 1 from here, and you get 3, 1. And then connect your dots. So what I've done was I've taken this graph and I've shifted it down 1 unit. What this is telling you to do, the 3 in front, is the C value. What do you do with C? A and B change, it affects your X value, and C and D affect your Y. So what this 3 would do in front is it's asking you to multiply all these Y values by 3. So you would graph -4, if you multiply this by 3, you get 0, -4, 0. Multiply this, you get -3, so -3, -3. Multiply this, you get 6. 1, 2, 3, 4, 5, 6, and then 3, 6. So this is your graph. What you've done is you vertically stretched it by a factor of 3. This one is going to ask you to take your Y values and multiply them, divide them by 4 or multiply by 1/4. So all of these Y values would be multiplied by 1/4. So you would graph -4, 0, which is this point right here. And if you multiplied this by 1/4, you would end up with -3, -1/4, which would be very hard to see. It's a quarter of, you're vertically compressing this graph by 1/4. And 1/4 of this is 1/2. So there, and then 3, 1/2. So it's very hard to see this one. You're flattening the graph. And the last one, you're shifting your graph 3 units up, you're adding 3 to your Y values. And so all you would be doing is taking this and moving them up 3. So you would add 3 to all these, you'd go -4, 1, 2, 3, 4, 1, 2, 3. And then add 3 to -1. And then add 3 to 4, which is 5. 2, 3, 4, 5. And then add, go across. The next 4 problems, you do the same thing. I would make a table of values. My table would include this ordered pair, which I'm going to call that -4, 1. I'm going to, you can call this point -1. Actually, it kind of has a little bit of a, this would be -4, 1. I would call this -3, 1. I would call this -1, 2. I would call this point right here 2, -1, and 4, -1. And all you do for these are going to be some vertical stretches and compressions, and this -4 is the B value. It's telling you to multiply all of these ordered pairs by the Y values, all get multiplied by -4. So you would graph, if you multiply these all by -4, your new table of values would be -4, -4, -3, -4, -1, -8. If you multiply this by -4, you get 2, 4, and 4, 4. Okay? So let's graph these. -4, 1, 2, 3, 4, 1, 2, 3, 4. -3, -4. -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. And we have 2, 4. And we have 4, 4. Okay, so this is our new picture. What we've done by multiplying the Y values by -4 is we flipped it over the Y-axis, the X-axis, and we've vertically stretched it by a factor of 4. For 47, all you would do is take, this is the parent function right here. These are the ordered pairs for 46. This is telling you to take all of your y values and just multiply them by -1. So you would graph -4, -1, -3, -1, -1, -2, 2, 1, and 4, 1. Here's your graph. So all that this is telling you to do is multiply the y values by -1. This one is telling you to multiply the x values by -1. So for this one, what you would do is you would graph 4, 1, 3, 1, 1, 2, -2, -1, and -4, -1. So and this would be a reflection over the y-axis. So 1, 2, 3, 4, over 4 up 1, over 3 up 1, over, and these would be connected, over 1 up 2, so connect that, then over 2, down 1, and over 4, down 1. So it looks like this. In 49, you're going to multiply the x values by -1/2. So take your parent function, and if this -2 means to multiply the x values by, you flip that and multiply by -1/2. So if you multiply this by -1/2, you would get 2. So you graph 2, 1. Multiply this by -1/2, you get 3/2 and 1. So 1.5, 1.5, 1. 1.5, 1, which is right next to it. It's very hard to see that. Then you're going to multiply this by -1.5. You get 1/2, comma 2, which is right there. And then multiply this by -1/2. You get -1, -1. And multiply this by -1/2. You get -2, -1. So that's that one. Back page, number 50. This one, you are shifting your graph 2 units right. So what you're going to do is take these ordered pairs and add 2 to the x values. You're going to add 2 to the x values. And you should get this picture right here. You added 2 to all your x values. The x values that I did were these ones right here: -4, -1, -2, 1, 0, -1, 1, 0, 2, -1, and 4, 1. And if you added 2 to your x values, you're going to add 2 to these values and keep these the same. For 51, you're going to add 2 to the x values and you're going to add 3 to the y values. What x and y values am I talking about? Again, these ones right here, and that's what your picture should be. So again, you're going to add 2 to the x, that would be a b value, and this would be a d value. So add 2, add 3 to the y. For 52, this would be a b value, and this would be a d value. You're going to subtract 1 from your x, and you're going to subtract 3 from the y, b and d, and that's what your picture should be. 53. For 53, you're going to want to rewrite this one as -f of x plus 2. This one is a reflection over the x-axis. You're going to, this is a c value, you're going to multiply your y values by -1 and then add 2 to them. So this is what the picture should look like. Again, multiply the y values by -1 and add 2 to that number. For 54, this is an a value and this is a d value. You're going to multiply your x values by -1 and add 2 to the y. Multiply x by -1 and add 2 to the y. In the last one, 55, you're going to take your x, that's a b value, you're going to take your x values and do the opposite, subtract 3. You're shifting your graph 3 units to the left because it's a +3. And that concludes 3.4 day 2.